All right. Cool. So over the last few weeks, we've been talking about a lot of different stuff. We've been talking about front end stuff. We've been talking about back end stuff, and we built some servers. We built some like different front end like HTML, CSS based stuff. And there's clearly a lot of stuff in both of those camps that we want to dive in on and keep talking about. But there's another topic that is really important for y'all to kind of just have awareness of as it relates to being in this full stack and understanding kind of the landscape that you'll find yourself in. And that is the cloud. And yeah, when you hear about cloud and cloud computing, it's always going to come up in just certain contexts as it relates to the ability to use and leverage resources that are virtualized machines from other providers in different capacities, right? And so cloud computing is essentially allowing for us to leverage resources that are operated by or owned by different providers in a remote sense, and we can use those computing resources for our own purposes. So there's a lot of benefits to using the cloud. There's alternatives that people use in different companies that you'll find in, but the principles of like virtualizing into certain machines and using machines as a server or using machines for extra computation capacity is something that comes up quite often and is very important to kind of know and be familiar with in general. So if you've heard about cloud computing before, give me a thumbs up so I know that y'all are right on time. Okay. All right. Cool. Cool. So there are a number of reasons why people might turn to like cloud computing. Does anybody want to shout out one reason why they think that using the cloud is important? Go ahead, John.
Easier way of storage.
Oh yeah, that's true. That's definitely true. Izzy, John, go ahead, bro.
Like, let's say you have like a bot that you need to be constantly on for whatever service it's on. You would put that on the cloud, so you don't have to keep your machine constantly running.
Okay, so like kind of allowing for you to create something that is that tasks that your machine isn't actually able to handle.
Also allow your data to be stored in multiple servers around the world.
Mm-hmm. Why is that important?
So there's like kind of the connection speed for like say somebody accesses it in another country, it could be kind of faster.
True, definitely, right?
I was gonna say access.
Yeah, that makes a lot of sense. Anybody else want to chime in here? What makes the cloud? Why would we might use resources in the cloud?
Easier to get to.
In what way?
Instead of having everybody, like in the instance of the COVID, instead of having instances of everybody in the office and then having to go home, now everybody can work as if they're in the office but from home. Flexibility.
Yeah, cloud computing really held us down during the pandemic for real. It's almost as if one of those cloud providers may have, no, I'm just kidding. Stop my conspiracy theories. But yeah, all these points that y'all are mentioning are definitely reasons why we might use the cloud, right? It provides us a way more access to, it provides us a lot more access to different machines. It allows for us to handle large amounts of data so we can do more data storage. And yeah, it really allows us to use and leverage more machines than we might be able to in our own current state with our own resources. So yeah, for all those reasons and more, cloud computing is really an important aspect of the landscape that we're working in. And it really kind of starts and ends with the same stuff we were talking about with relationship to the why we need servers in general, right? So we're using these computers to do so many things. And ultimately, we want those computers to allow for us to handle like so many different things that require at certain points for us to just require a lot of capacity, right? And our normal computers could theoretically do it and act as a server, but as we know, it's not actually as beneficial for us, our computers, to be in charge of a lot of those things when there's clearly going to be certain limitations to how much our computer running as a server can actually do. And then things like, hey, you want to configure certain things about the network to allow for people to, actually reach your machine and things of that nature. So there's a lot of reasons why certain times you can't actually just use the computer that you're used to using, because of the fact that there's a lot of differences between how your computer works versus how like a computer that's programmed in the cloud can work. So there's a number of different cloud computing providers that you can leverage in your technology journey. So let's go ahead and talk through some of them. So let me pull up the browser for y'all. All right. So dope. So one of the largest cloud computing providers that you'll hear about often is Amazon Web Services, AWS. Give me a thumbs up if you heard of AWS and Amazon Web Services. Right? AWS is is Amazon's cloud solutions, right? So web services basically are, they've created software that allows for you to access their resources in the cloud. So what's cool about the cloud, right? If we just kind of just browse the AWS website, you can see a lot of the stuff that's possible by way of leveraging cloud computing, right? So all these things from like high-end like data things, like data intensive stuff. Like I think we saw something down here about like machine learning, right? Like serverless computing, storage, right? There's so many things about those types of activities that make it so that you can't just rely on one computer to do everything. And having the ability to leverage multiple computers makes it so that you can leverage those resources in the cloud, right? So things like compute power, database storage, content delivery, or other functionality. AWS has the services to help you build sophisticated applications with increased flexibility, scalability, and reliability. In this one sentence, they're articulating a lot of the values of the cloud in general, right? Compute power, which is some of what y'all said, like when you're processing a lot of information and you want to run like some serious algorithms, you need a lot of bandwidth on your computer that you might not have on your personal laptop. You could use a cloud computing a machine on the cloud to do, right? Database storage, clearly like we are going to use databases and need to host databases, and databases typically are hosted also on a server. But the thing about databases is the more data you add to it, right, the more memory it takes up. And the more memory it takes up, the less that your computer has for other things. And that can become a bottleneck. So creating the database configurations that allow for you to host your database in a way that allows for it to scale as your program scale is something that you can achieve on the cloud. Content delivery, somebody mentioned like the idea of like having something be accessible to people across different places, right? Like depending on where you live, like reaching information on the internet can still be kind of tough depending on what networks you have to reach. So what people do is try to host different information in different hubs so that people can get access to information and data faster. So content delivery networks are something that get created to make it easier for you to manage all of this data and do it in a way that, like they talk about here, is flexible, scalable, and reliable, right? Flexible, meaning that like, if you can change it from what you need at different moments in time. Scalable, meaning like at a certain point, if you have to go up, you can go up, right? And then reliable, meaning it's always there, like it's present, right? So if we want to have long lasting applications, right? If we want to turn these web applications we're building into something that are long lasting, we need to have them reliably available for people. And some of that comes into like our part in just engineering, and some of it comes into the part of like, how do we put the code in how are we running the code? How is it organized? How is it operating on a machine so that we can keep it up reliably and make it so that people have access to it all the time. One of the like cool things, I'm trying to see where I can find this, but there's a really dope white paper from AWS that articulates one of the all of the, like kind of the core functionalities that it has within it. Definitely recommend if you're interested in the cloud to like read up in these areas, because there's a lot of information. But they're talking about a lot of the different, a difference of, yeah, I'll look for it and I'll send it to y'all and put it in the chat or something. But there's a lot of information that comes about, like it might be the well-architected one now that I think about it. But essentially, there's a lot of information that comes about anything related to the cloud, right? There's a lot of different services. Like Amazon has a lot of different services that you can use in their platform. The most important services though that like are that we use the cloud for, definitely storage, right, is a huge one. And so in Amazon, there's a few services that allow for us to do to store the data that we're working with. And so in Amazon, those services are like normally like S3 is one of the web services for storing data, and another one is computing, so compute capacity, so using virtual computers. In Amazon, we use what are called EC2 instances to do computing. And then beyond EC2's storage with S3 are some of the most important uses that we use for the cloud, right? Using the virtual machines, connecting those into instances, and then using storage of the computing provider that we have here. Let's take a look at some of the stuff that they're talking about on this overview of the thing. So cloud computing is on-demand delivery of compute power, database storage, applications, and other IT resources through a cloud services platform via the internet with pay-as-you-go pricing, right? The idea about the cloud that makes it so intriguing to folks as an opportunity is the fact that you can pay as you go for these resources. So instead of having to buy physical servers yourself, you can just use someone else's server and almost say, hey, I'm renting it out to do this amount of work. And they have pricing that is varying based on how much you use it, right? And so whether it's in compute stuff, like we were just talking about, like these instances that you could throw up, database, right, where you can use certain web services to launch full-scale databases, storage, like we talked about with like things like S3 that allow you to store objects and things of that nature. You can pay as you go for those things. So as engineers, right, when we're trying to build code out, it's sometimes important for us to use these things, and this helped create an opportunity for us to use them in a lower cost capacity that also is scalable if we need to use more of these resources over time. So like it says here, with cloud computing, you don't need to make large upfront investments in hardware and spend a lot of time managing that hardware. Instead, you're allowing for someone else to manage the software, manage the heavy load so that you can just use it as a service. Yeah, so some of the advantages of cloud computing: trade fixed expense for variable expense. So like we just talked about, pay as you go makes it so you don't have to have these big upfront costs. You can just have it be something that changes over time based on how much you use it. Benefit from massive economies of scale. So it's saying, hey, you know, over time, if you're using these cloud computing things, you can really make it so that your over time you're able to make it so that these platforms make it so that the cost of using it is less. So things of that nature, like the more people use it, the cheaper it can be, the more people that can use it. You know what I'm saying? Capacity stuff, making it easier for you to use the right amount of data and storage over time. So instead of having to guess, you have like, hey, based on however much information and data I'm using, I can use the cloud to make this easier for myself. Speed and agility, it says like, hey, you can go live quicker. That's true. Make things available to yourself faster. You don't have to maintain these data centers and big kinds of things, and you can go global in minutes. So have things from around the world all over the place. Let's see what it says here about types. This is actually really dope. This is what I was going to talk about. So there's different models in which you can engage with cloud computing as it relates to understanding the different levels of responsibility that you might want to maintain when it comes to building out a platform. So some of those, each of those different types of management of your services require different levels of like your own kind of bandwidth and your own kind of management and maintenance and things of that nature. And so cloud computing companies typically try to make it so that you can choose how involved you want to be with your particular systems. So on the one hand, we have these different types of layers of complexity. We start with like infrastructure as a service, platform as a service, software as a service. And so I want to show maybe there's a helpful graphic that we can see versus just talking about it and just seeing it in kind of the text. I like graphics. Yeah, so let's see. Dang, you gonna do me like that? they gonna do me like that? That was not trying to be clear. All right, cool. There it is. All right, lit. So here's the different types of kind of layers of complexity that you can manage with relationship to your cloud-based software. So let's start on the left side, right? On the left side, we see what it calls on-site, or sometimes it's referred to as on-prem or on-premises, meaning like you have your own server, right? So let's say, for instance, after I told y'all, hey, we're gonna build a server in the back end. We built the server, like the running server on Express, but we're like, oh, we need a computer to actually host this server. So we're like, oh, okay, let's just go buy one. And we're like, our girl Jess is balling. She's like, I'm just gonna buy y'all a server. And we're like, all right, just got racks, you know what I'm saying? Like, and now we got a server. So what would have to happen for that server to actually work with relationship to our application and the server that we built in Express? Well, the first thing we'd have to do is we'd have to connect that server to the network, to the internet, right? There's like a physical and software-based thing that has to happen that allows for our computer, this new server to be connected to the larger internet network, right? A lot goes into that. And it's a physical as well as a digital based process that needs to take place in order to connect that server, both from an operating system level to like its actual functioning on getting into the internet. The next thing we'd have to figure out is stuff like storage. Like, okay, well, what is the memory going to be happening on these particular systems and stuff like that? Do we want to create and instantiate these different servers or whatnot? Like, we're gonna have to manage all of those different things. Like, what actually are live and exposed for different users to use? Are people able to come into our machines? Are they able to virtualize into our machines? Virtualization is the process of being able to say, I can remotely get into this machine from a different place. Every computer has an operating system. So we'd have to figure out the operating system and like, what is the, what operating system is running on that computer? And like, how do we want to handle that, right? do we want to put any middleware between like the software on our operating system and like kind of the running platforms that we're going to be building and whatnot? Any runtime processes, and then eventually we're going to create the data that we need and build the applications like this Node.js app that we built that is running our actual server, right? Which abstracts away a lot of the logic underneath, right? This is the type of stuff you manage when you have systems internal to you, right? So some people opt in for this. Why? Because they can manage all of these different layers of the process, right? They have full control over their entire systems versus in certain regards with the cloud, the value proposition is instead of having to manage all of these things yourself, give some of this responsibility away to some of the cloud provider to manage for you. And that's where these 3 different models come in for the types of cloud computing that you see people engage in these days. The first one is infrastructure as a service. And infrastructure as a service is basically where the cloud-based provider manages the infrastructure of your systems for you. So the infrastructure would consist of the networking, storage, servers, and virtualization, allowing for you to control things like what is the operating system, middleware, runtime that you're going to use, and the data and applications that run on top of that, right? So you opt out of having to manage all of those things. The other is platform as a service, where the cloud-based provider provides you a lot more, manages a lot more for you in terms of not only the infrastructure, but also some of the platform kind of requirements. So like they choose an operating system, middleware, and runtime that works. So all you have to worry about is what's the data and the applications that I want to run on a particular platform. Software as a service is the third, right? And we probably, give me a thumbs up if you ever heard of the term software as a service, and you're like, oh, I've heard of that somehow. So software as a service is this idea of the cloud-based provider is managing everything in the process of you running an application. So instead of you having to, if you were like the engineer behind it, right? You don't have to manage anything beyond actually putting your application up on the cloud and people can access it, right? And in a lot of ways too, software as a service makes it so you don't have to, you're not responsible for all of these different pieces as well. So these are the different kind of levels of like the cloud that you see people engage in. And like I said, people engage in different levels of it because at the end of the day, there's certain cases where you might want to manage some of these aspects. And now there's certain platforms and sites and things that do some of these things for us in different ways, right? If we think about our favorite applications on our phone or whatnot, like a lot of those are software as a service based applications, meaning they run in the cloud, we get access to them, and the engineers don't have to do anything for us to replicate their application over and over and over again, right? That's achieved by way of the cloud, which is why it's been such an exciting business model for folks, because as we talked about with why the cloud is variable costs. So people know what their costs are at different points in time. And it allows for this massive scalability, as we've seen over the last few years with relationship to applications that suddenly go viral and not everybody's using them, right? If you ever think about how does an app achieve that ability to be like in everybody's hands all at once, right? It requires a whole lot of back-end networking and like creation of an application that allow for this type of scalability. Isabel, I think you raised your hand. You have a question there? Okay, dope. Any questions? If it's making sense, give me a thumbs up though.
Yeah, so does this mean like on-site jobs versus like SaaS jobs or whatever would be like less, like SaaS jobs would require a bit less work and maintenance overall for like the developers?
So the developers are only, as most times when you're developing, and if you're an engineer in like just a developer sense, you're working on the first two layers. Or like, yeah, most times, unless you are responsible in your organization for setting up like the servers that you all are running on in a hardware space sense, which is some of what goes on in the infrastructure phase. So different types of engineers work on different parts of this stack. This is a completely different stack. All of the stack we were talking about, right? Application layer is us. That's where we were talking about before, and maybe some of the data on the data side. So people who work in companies that are SaaS-based companies typically work on, if you're like a full stack engineer, you're always going to work on the application layer. If you're interested in getting into more aspects of like how that is working, then you start getting into like network engineering and like a way more kind of sophisticated backend stuff that relates to the actual kind of inner workings of those machines that is kind of in between platform and infrastructure. So it doesn't really relate to like how much work you do as an engineer if you're coding, if you're just a software developer. But this is just about like how companies have to manage the systems that then you build your application on, or that computer that is running the code for you or whatnot. Does that make sense? Like if I give you another example, it's like this. When you ran your server, you just used Express, which is an application and it's using data, but Node is doing a lot of stuff in between to connect with your operating system to allow for you to use a server, right? And then beyond that, there's a lot of stuff with relationship to your machine that is kind of turned off in the sense of like virtualization and like other server stuff. And there's layers to how deep you go with relationship to all of the stuff that you can do as an engineer. We just kind of touch the tip of the iceberg every time we write our code. Any other questions? Dope.
Wait. Oh, I have a question. So basically, like leaning more towards like networking programming is like that's more of the DevOps job sense. Oh, okay.
Yeah, so there's folks in between kind of networking, like there's network engineers that just have a job being network engineers. And then there's also like folks that focus on like kind of like, you know, systems administration and like IT and stuff like that, that are kind of all related to some of these different parts of management of on-site or cloud-based systems. Then as an engineer, software engineer, full stack engineer, you have the opportunity to tap into these different layers of the complexity, but then you're getting exposed into concepts beyond just like me in a programming language and now you a programming language and more of the machine and the networking, or, you know, like the operating system, like, and that is where you start getting deeper into your craft and able to build more and architect more systems that are able to achieve like scale and things of that nature.
So networking is just making sure that everything is properly connected, running together.
Yeah, and connected to the internet. And yeah. Good questions. Dope. So there's different layers to and levels to like how involved like a cloud computing system needs to necessarily be. And yeah, I encourage y'all to kind of read about some of the different ones. And in the case of us using GitHub the other day for like GitHub Pages, right? We use GitHub Pages to just host our application for us, right? In that example, we were kind of just using it as a platform, right? We didn't have to pay because it was free, but essentially GitHub Pages sorted out all of the stuff for creating a platform for our code to run on our little website that we did on GitHub Pages. We just provided the data and the applications that were necessary. And even then it wasn't even that sophisticated because it was just a little bit of code for HTML and CSS. But there's other platforms kind of like, there's other platforms like Heroku, right? That are dedicated platforms as a service, right? And so like these kinds of tools allow for you to, these kinds of tools allow for you to host entire applications without having to worry about like the infrastructure behind them, right? So Heroku is like one of those examples, a good example of like a platform as a service. You can use Heroku as a platform for your code. You just provided the data and the applications you actually want to run, and it will run, it'll do the rest of like figuring out like, how do I create all these multiple instances and servers and things of that nature, and the storage and this and third. So yeah, there's some cool tools that come and emerge from just being able to leverage the cloud. So we talked about AWS, which is definitely one of the more popular like kind of cloud providing cloud providers. But the other two that are equally worth mentioning are the Google Cloud Platform, which is also very kind of sophisticatedly up there. But both of these platforms offer similar services, right? So Google Cloud Platform also has a bunch of services that you can utilize for your particular projects and products. So when you start getting into it, right, you see some of the same like language, right? Compute. This is the same stuff we were just talking about, being able to actually run instances of virtual machines that you can use and call out and put your information on, right? Being able to scale and deploy those things very quickly. Storage, same thing, being able to like store data and be able to store data in a number of types of ways, whether just kind of in general, right? If you think about Google Drive is an example of storage in the cloud. We use Google Drive. It has an entire interface to it, but if you think about what's happening in the back end of that, how does that even work, right? Well, Google has to provide certain machines that are full of databases that are holding code. And even without the databases, just hosting that code on a machine, just storing the data in and of itself, right? We can use Google as a tool for that. They do have tools specifically for databases where we can manage specific types of SQL or NoSQL databases that are more full-fledged databases, taking up memory and saving things in a more in a different capacity. But yeah, and then on top of that, every cloud provider has different tools that are more helpful for developers using their tools, right? So if you're into data analytics, you're probably going to want to use some cloud provider tools, because a lot of the data analytics, especially when you're working with big data, right? You can't rely on just your machine to run some of these types of pieces of code. So we leverage cloud software to do this. AI, machine learning, all of this happens in the cloud. This doesn't happen. You could probably run some small scale instances on your local computer, but if you think about it, like the type of computing processing that you might require to like run and learn, teach an algorithm, train a model and stuff, could take a lot of energy off of your computer, like memory and storage. And doing it in the cloud makes it that much easier. Yeah, and then networking in general, like being able to create security and like say, how do you want these different instances of computers to be accessed, which you can achieve well in the cloud through Google Cloud. So yeah, so cloud computing kind of can happen in a number of different places, whether it's AWS, whether it's Google Cloud, and then the last and another one that's really important to know about is Microsoft Azure, which is Microsoft's cloud computing service, right? And so when you look at kind of the landscape, you'll see people talking about like cloud-based stuff in all of these different places, right? And so each of these big companies have provisioned resources that they own. So actual servers and computers they own, and have basically made those computers accessible for folks in the public to use in a pay-as-you-go sense. And that is what the cloud computing industry has been. There's these are like the big players in it. Clearly, Microsoft, Google, right, Amazon, have enough money to buy that many servers and do that many things. And oftentimes, as engineers, you don't have that money. So you want to use systems that make it easier for you to achieve what you need to achieve without having to put up all this money that you might not have. You might find that people are using different ones of these based on what companies you're applying to. Having familiarity with them, though, allows for you to identify more opportunities for you to be helpful in the work that you do, because it might not be the case that you have to go and provision the whole server or do all of the network logic in the actual instances that are running. But if you've built applications that leverage some of these cloud providers and tools, you are working in an ecosystem that's similar to what these companies would be doing generally and what their code might be doing. And it increases your likelihood of understanding some of the complex things going on in their code, which is why I'm saying that it's important to know about these different types of cloud providers and what they're doing, right, and how they work in general. But as it relates to you as an individual engineer, like working with the cloud can just look like you using some of these services in your own applications and in your own ways, right? So whether that is in like leveraging like in like an AWS sense, like being able to store, they're all these cloud providers, man. Being able to store like information in like S3 or something, right? So being able to use storage in Amazon for a site, right? Instead of having to save data. If you're trying to save data, maybe you can save data in a cloud database or something, or in a cloud storage provider like S3, or you could use a cloud database, right? These are different types of, there's different reasons why you might use different types of cloud providers, but it always will come down to like, what is the service that they're offering? How easy is it for you to bring it into your application and use it for the benefit of what you're attempting to do? And yeah, between all of these different types of cloud providers, talking about some of the values that come from the cloud in general, right? There's a couple different types of models that you see people using in the cloud. Fully cloud or cloud native is like kind of like applications that are started and created in the cloud and have like full access to like all of the cloud computing capabilities. Hybrid are applications that are kind of like a mix of cloud-based and also like on-premises based systems and resources. And then fully on-prem is like resources that are basically like they have specific resources internal to them as a company, and they're using that and not really using like a fully scalable cloud-based system. So some places still use like very much on-premises servers. Those are the companies where you go to the company and they have a server room, right? How many of y'all have heard of like the server room, right? Like you go to a company and they're like, oh, this is our server room, right? That is what they mean by like on-premises. Like in an on-prem environment, those servers are internal to the org. They use them, they connect to them and all of that directly. But if they ever needed way more servers, then they kind of can't. It's like, where would they do? They would normally buy more servers, right? But with the cloud, you can achieve that type of scalability without having to buy like a huge machine and stuff like that, and then provision it, configure it, and all this, that, and the third. The cloud provider can manage that for you. So yeah, there's a lot of different positives and use cases to why you might use the cloud. But it all will depend on like the nature of like a scaling organization. And as full stack engineers, like sometimes you don't necessarily need all of this information up front because you're still working on like front end and back end stuff. But it's helpful to know like when it comes time to like deploying that front end website, like where would you do? Well, most people would be deploying it onto a cloud-based system so that it can be accessible in so many different ways. When it comes time to figure out how we're going to build that database that's going to be connected to our server, oh, well, we might use a cloud-based database to do that. Deploying the whole application in and of itself onto a server that's running and has an IP address that is like reachable by somebody else, right? We can do that by changing the networking permissions on a server instance. And normally we might do that in the cloud versus on our local machine. So that's where a lot of that stuff comes up and is important to understand. But yeah, if everything I'm talking about makes sense, just give me a thumbs up so I know that you're rocking with me. And I am gonna take a break from talking because it's time for a while.